Hi guys, I know you've been recently asking me about the LiFePo batteries and Chinese versions of them. So this time I received PFDD 12 volt 200 amp hours, which sounds nice, LiFePo4 battery. It includes BMS for controlling the power and voltage drops, as well as temperature. And, well, they say that this battery can hold up to 200 amps, like normal discharge current is 100 amps. So during this test we'll do the capacity test, as well we'll do the temperature test of how this battery performs. So let's continue exploring these battery features of stated 200 amp hours lithium battery. If we're looking at the technical specifications here, we can see that, I'll zoom it a little bit, so for it to be more convenient. We have stated that it's 200 amp hours battery pack, that maximum charging current is so high, instantaneous discharge current is 200 amps. Okay, so this is for a very short period should be, but continuous discharge current constructed to be 100 amps. We will see how this battery performs under the similar or even lighter loads in regards to the temperature. Before starting the charging test, we fully discharged the battery up till the point when the voltage on external clamps dropped below 4 volts. The voltmeter shows something 3.3 or something. I'm showing that on the picture. And the dashboard of the battery itself shows that it's below 10.5 volts. For the charging, we used iCharger professional equipment with settings of fast charge for LiFePo batteries with 20 amps as a max. As we recall, the battery specific says that it can be charged up to 50 amps. So we are below half of the settings, so this is normal charging cycle. And let's see how it goes. For a short period of time, I needed to connect, at the very beginning of the test, I've connected the original battery power supplier, because this professional equipment protecting the battery doesn't start if the voltage is below the lower level. And as you recall, we have a BMS in this battery, which switches off the original power from the cells and provides only few volts on output when the battery is fully discharged. So we just boosted the battery, it started, it opened the voltage, and then we started the charging cycle. For the testing, I used both iCharger and GT Power RC with a high precision wattmeter and power analyzer. However, the lighting conditions were not so good, so you can see only one measures clearer and another one. I'll provide you the photo at the end of the sequence. Now you can scroll through that quickly up to the point where the charging ends, and we'll discuss the results. I used the time-lapse mode on the camera, however it took still something like 10 minutes. So right now I suggest you to jump to 13 minutes on this video, and we'll discuss the results of the charging the fully empty battery till the fully full battery. As we can see, iCharger presents us with 86 ampere hours, so you can recalculate it, 4 hours 45 minutes by 20 amps. At the end, actually, it's slower, because when you're coming to the end of the charging cycle, the current drops down, so there will be less power at the end of the charging cycle. And GT power shows 65 amp hours, most probably because difference of the voltages which GT power was receiving, the readings of voltage was dropping a little bit, therefore it calculated less amp hours. So we see that it's difference of 10-20% here. And because the iCharger is pretty quick on charging, but discharge can only be done on 20 watts, so charging is 300 watts and discharging is 20 watts max, it would take us few days or even more to discharge this capacity. Therefore we will use only GT power, and we'll assume that, okay, even if it will show us less amp hours, we can add something like 20% to that reading. Okay, let's see how discharging will go now. And the last reading, which was captured by the camera, was 65 point something ampere hours on this battery, which actually you cannot expect that you will get more from the battery than you charged it in previously. But as we see, that's pretty efficient battery, only the capacity is more than 2 times less than expected. For the next temperature test, I took a CAT phone with a FLIR thermal imaging sensor, and what I've done, I have applied the 90 amp load to this battery and was measuring it for 2.5 minutes. You will see that in the next movie, how it performs, how it goes. We're applying load, and let's see how it goes. On 90 amps, the voltage drops down to 12.3 volts. Okay, that's okay. And the heat increases. So it's only a few seconds and it's already over 50 degrees here. And here, not so bad, 28 only. Let's see how picture changes. You can see the temperature rises. It's 49 degrees on the top right corner, 50, 51. So it's 90 amps only. And after finishing the test, I removed the wires and made a few photos with thermal imaging of how this battery looks after applying 90 amp load. As you can see, the temperature reaches almost 90 degrees Celsius when applying 90 amp load. You could imagine what would happen if we apply a design 200 amps to this battery. However, interesting point here is that the increased heat is only on a positive clamp here, while on a negative it stays normal, something like ambient, a little bit higher than ambient 30 degrees Celsius temperature. One of the most interesting things was that when I've sent the photos and the notes regarding capacity and heat problem with this battery, I received the answer from the producer that I've used wrong equipment to test the battery, and they stated that this voltmeter, this Mustech voltmeter, is not suitable for that. Actually, yes, it's not used here for any capacity measures. It was used to provide that there are some problems with dashboard of this battery and the real readings which are presented on the clamps. So for example, on this picture here, which I provided to AliExpress and to the seller, you can see that Mustech voltmeter shows 10.58 volts. The GT power analyzer shows 10.59 volts, and the dashboard shows 11.2 volts. Well, that's not a problem at all, but based on that reason, they declined my money, or at least a part of the money return request to the seller, that the problem is capacity is twice or even triple less than declared, and I cannot use it for higher power modes. I mean, you cannot use this battery with high amp applied to that, because heat increases too much, it will melt the plastic. It actually started to melt the plastic. So guys and girls, finishing. It's now up to you whether you decided to buy and use this battery, which is twice less of a capacity and has some problems with higher loads, the temperature problems. I hope it will not burn, but it may melt the plastic, may melt your wiring, and, well, potentially it may lead to some fire in your truck or wherever you will use it. So beware, be careful, and a good luck. Happy camping!